Yeah, good morning, students. Now onwards, we are going to study about what in your syllabus as present your syllabus. Okay, what we had previous class we discuss about discovery of electron, proton, neutrons, all subatoms, but it is not in your syllabus. To know that basic concept, you will be further it will be helpful to you. Okay, next we are going to study about nature of magnetic radiations, wave theory of radiations. You see, this wave theory of radiations was discovered by Maxwell. Okay, what he told that if light is moving, see, this is a diagram what we are going to write. First, I am going to write this magnetical field. So the magnetical field, okay, I will mention it is magnetical field by denoted by B dash. Another I am going to write is electrical field. See, it is electrical field denoted by E dash. Okay, it is in x directions, correct? Now it is, we'll take here directions x, it is x, it is y, it is z. These are the directions. You see what he told, Maxwell told that light is transmitted in the form of electromagnetic radiations. Light is transmitted in the form of electromagnetic radiations. We can write that EMR, nothing but electromagnetic radiations. Means light is transmitting in the form of magnetical and also electrical, both for that electromagnetic radiations. You understand the first point. The second point we are going to study, the electrical and magnetic field are perpendicular. You see, this is perpendicular, no? Magnetical, see, this is magnetical, this is electrical. They both are perpendicular to the pathway. Means you can write electrical and magnetical field acts, correct? No, acts perpendicular to the pathway. Okay, next what we know by seeing this diagram, another one, the electromagnetic wave travel in vacuum and does not require any medium. You see, light does not need any vacuum or any medium. Okay, next point we are going to write is electromagnetic wave travel in vacuum and does not required any medium. Any medium means air medium or water medium or oil medium. Okay, like this way I am talking that any medium. Next, while seeing these electromagnetic radiations, the wave theory of radiations, we know some characteristics. That characteristics are, we'll write characteristics. That number one, wavelength. It is denoted as lambda. What is this wavelength? You see, the wavelength you can take while seeing this diagram, you can take by ear to ear, means one of the two clusters. It is nothing but wavelength. It is denoted as lambda. Okay, means wavelength is denoted as lambda. Second one is frequency. How much frequency the light is traveling? Frequency denoted as mu. Third one is amplitude. It is denoted as A. Fourth one is velocity. Velocity is denoted as C. Fifth one is wave number, mu bar. Okay, next we are going to study about wave frequency and amplitude. Okay, well, before talking this, we are going to read what is this wavelength. Correct? No, wavelength, if you write one diagram, for example, I am taking a small diagram to understand you. I am taking small diagram. This is crust. This is tuff. You see, the amplitude is nothing but this is the amplitude. How much the wave is increasing. It is denoted as E. Correct? No, it is amplitude. It is measured in meters, centimeters. Amplitude is measured in meters and centimeters. What is this frequency? Frequency is nothing but one crust and one trough. Is nothing but frequency. What is wave number? It's nothing but crust. It is wave number. Okay, this is what we are going to see. Next, we are going to write wave frequency. We talk on that wave frequency amplitude. Correct? No, we are going to talk about a property, formula, and units. Wave length, frequency, and amplitude. Wavelength, frequency, and amplitude. We make it three columns. That is, one is a property, formula. Another one is units. Which units will be measured? Okay. First, we are going to talk property. That is a wave length. It is denoted as lambda. We know that formula. We know the formula. C is equals to mu lambda. C is equals to mu lambda. C is nothing but velocity. Mu is nothing but frequency, and lambda is nothing but wave number. If you want to find out the wavelength, lambda is equals to you see c by lambda is equals to c by mu. Then the units will be taken that for to measure the wavelength. 1 Armstrong is nothing but 10 to the power of minus 8 centimeter. If you want to convert into meters, is equals to 10 to the power of minus 10 meter. If you another units are there to find units for wavelength is 1 nanometer is equals to 10 to the power of minus 7 centimeter. Nanometer is nothing but 10 to the power of minus 7 nanometers. If you want to convert into meters, 10 to the power of minus 9 meters. One is another unit is there, 1 micrometer is equals to 10 to the power of minus 9 meters. Do you understand the units of the wavelength? Next we are going to study about frequency. To find out the frequency mu is equals to c by lambda. Two units are hertz, CPS is nothing but circles per second. I want to write it this hertz. CPS is nothing but you see CPS is nothing but cycles per second. Okay. Next another one is there, velocity is denoted as c, frequency mu, symbol c, velocity. To find out c is equals to mu by lambda. It measures meter per second or centimeter per second. Okay. Last, wave number mu bar is equals to 1 by lambda. We know lambda is nothing but c by frequency, while if you take 1 by lambda or 1 by c by mu, we can write this is mu by c, correct? No, we can write mu bar is equals to 1 by lambda or mu by c. Okay, it measures the units centimeters per centimeters or meters. Okay, next we are going to take another one important topic, that is what is velocity. We are talking that wavelength we know that, frequency we know that, correct? No, wave number we know that. How many wave numbers? Okay, well I already explained that. I have not explained about the velocity. Velocity is nothing but the distance traveled by a wave in 1 second. Distance traveled by wave in 1 second. I will write here only the velocity. C equals distance traveled by wave in 1 second. Okay, if the light travels in air, so or light, or we take a sound. First we take a sound in air. The velocity is nothing but 340 meter per second. 340 meter per second, the velocity, sound is moving in air. Okay, similarly sound is moving in water. For example, 1400 meter per second. 1400 meter per second. Another one is light. We are taking light moving in vacuum. Vacuum is 3 into 10 to the power of 8 meter per second. 3 into 10 to the power of 8 meter per second. Next we are going to study about electromagnetic radiations. Okay. While going to study about electromagnetic radiations we are going to study what is electromagnetic spectrum. What is electromagnetic spectrum? You see, electromagnetic spectrum. Okay, I am taking one wave is moving. Okay, I am taking one wave. Okay, moving. I am taking if one is wavelength, another one is frequency. Okay, if wavelength increases, the frequency must be decreases. If frequency decreases, the wavelength must be next. I am going to write that which the lines will be forms the rays, spectrums. Okay, I am going to write okay. First we will see this gamma rays. It is approximately not, it is 0.0001 nanometers. I think already I told what is nanometers. Gamma rays first, another one is X rays, (10 nanometers), UV rays, another one it is visible. I will write here visible, rays. Next is infrared. It is 1000 nanometers to 0.01 centimeters. Another one is 1 centimeters. Next one is radio waves, 1 meters, 100 meters. You see what I am writing this as our electromagnetic spectrum. You written that the frequency what you are writing, that frequency one is lambda. It may be a wave. I am talking that wave. Light is moving. Okay, light is moving from sun to you take. You will have different radiations. Some of the clouds will be absorbed. See in visible onwards. Okay, we can see this visible onwards. We can see this. We cannot see this gamma, X-rays and UV. You can ask me, sir, X-ray shield we can see in sheets. No, I am not talking the sheets. I am talking about the radiations. Okay, that visible. You see, in visible we can see Waveguide. Already you know that. I think I don't want to tell what is VIBGYOR. Correct? No, it is 700 nanometers. 700 nanometers from visible to we can see, but cannot invisible only we can see that. In infrared we cannot see the radius waves also we cannot see. You see, it may be decreases or increases the wavelength and frequency we cannot see. So particular meters, 700 nanometers, we can see the Waveguides. Correct? No, Waveguides. I think a rainbow you have seen while falling that in water particles. 400 nanometers to 700 nanometers we can visible. Okay, other 1000 nanometers we cannot visible. Okay, if it decreases or increases the wavelength we cannot see. We can particularly 400 to 700 nanometers. What is this electromagnetic spectrum? I written that some diagram. I written told that rays. Correct? No. What is the spectrum? You see, I am going to write spectrum is an array is nothing but arranging of waves or particles, they are spread out according to, you see, means spectrum. What is spectrum? I am not told, correct? No, I write on the diagram. The spectrum is array, means arranging of wave. Wave is arranging, which goes on increasing nanometers to meters, 0.001 nanometers to 100 meters. It goes on increasing the wavelength, means it is arranging. Wave or particles, they are spreading, correct? No, they are spreading. It's quite common, spreading out according to increasing or decreasing of frequency and wavelength. Do you understand this? What is spectrum? I am going to write the definition. Spectrum is an array of wave or particles. They are spread out according to increasing and decreasing order of the frequency of wavelength. Do you understand this? What is electromagnetic spectrum? To explain the electromagnetic spectrum, I had written the diagram. It is arranging of wave or particles. They are spread out according to increasing or decreasing order of frequency of wavelength. Next we are going to study about continuous spectrum. Okay, continuous spectrum. The word only we can understand. The continuously spreading, correct? No, we take here white light or sun, while coming from sunlight, or any incandescent lamp. We are taking three, that is light, white light, or sun. From sun we get radiations, no? Sun or incandescent lamp. Okay, the white light is nothing but light waves. It frequency 400 Armstrong to 800 Armstrong. Sorry, it is wavelength. Light wave is nothing but 400 Armstrong to 8000 Armstrong. Okay, I am taking that prism. I am taking a prism. This is prism. I am passing the light. It is nothing but white light, or correct, no? White light with different lambda, means wavelength, lambda 2, lambda 1, lambda 3, so on. Okay, different wavelengths. Okay, passing the light as deflected. You see, will get 1, 2, 3, 4, 5, correct, no? 6, 7, 8. First we get V, B, I, B, G, Y, O, R. The violet violet has found in 4000 Armstrong. When come to red it shows 6500 Armstrong. You can ask me that, sir, you told that white light 4000 Armstrong to 8000. No, the wavelength is passing you, but you getting 4000 to 6500 Armstrong. What about other? It means some of the will be absorbed by the prisms, some of the light. Okay, this is nothing but, you see, this is continuous spectrum. What I am telling that while writing the definition, there are series of bands. This is will be bands, correct? No, the bands that forms as continuously a rainbow of color. Continuously rainbow of color. You see, this series of bands. We're getting a band. Band means you don't think that what you are wearing the band, not like that band. It's a band means I will explain in next class or next topic. Band that forms a continuous rainbow of color. You can ask me, sir, we'll get the rainbow in the earth if we will not keep any prism or anything. You see, while the radiations from the sun, it falls on the water drops, it will be reflected, that we get the Vibgayas. You understanding that? First we are going to, you understand this? Next we are talking that wavelength. Wavelength is where wavelength is more or less in Vibgayas, correct? No, means violet having shorter wavelength, correct? No, when come to for wavelength is shorter. What about frequency? Frequency is higher. Is frequency. Okay. When come to next to least, red, correct? No, red, what happens in red? Longer wavelength means it will be long wavelengths. You understand here? In red, in violet it will be short, like this, longer wavelength. What about the frequency? Frequency will be shorter frequency. This told the continuous spectrum. Next we are going to study about atomic spectrum.